Hey everyone, welcome back to Daily LeetCode channel. In today's session, we are looking at the LeetCode daily problem titled 3531, Count Covered Buildings and its medium-level problem, using the topic's 2D array, hash table, sorting. Let's begin by understanding exactly what the problem is asking. We are given a positive integer, n, which represents the dimensions of an n by n city grid. Within this grid, we have a list called buildings, where each entry is of the form x, y. This pair represents the coordinates of a single building, and the problem guarantees that every building listed is unique. Our objective is to determine how many of these buildings are considered covered. A building is classified as covered if and only if there exists at least one other building in each of the four cardinal directions relative to it. A building somewhere to its left, a building somewhere to its right, a building located above it, and a building located below it. So the requirement is not about immediate neighbors. As long as a building has another building in each direction, regardless of distance, it qualifies as covered. Our task is to compute and return the total number of such covered buildings. That's the complete problem description. Now that we understand what is being asked, let's move on to the solution approach. Now that we understand the problem statement, let's walk through the examples provided to see exactly how covered buildings are identified. Example 1. Input, n equals 3 buildings, is 2D array of 1, 2, 2, 2, 3, 2, 2, 1, 2, 3. Output, 1. Explanation. In this setup, we have 5 buildings arranged so that the building at coordinates array of 2, 2 sits in the center. It has at least one building in all 4 directions. Above it at array of 1, 2, below it at array of 3, 2, to the left at array of 2, 1, and to the right at array of 2, 3. Because it satisfies all 4 directional conditions, only array of 2, 2 is considered covered. Therefore, the total count is 1 point. Example 2. Input, n equals 3 buildings, 2D array of 1, 1, 1, 2, 2, 1, 2, 2. Output, 0. Explanation. Here, we have 4 buildings forming a small block in the top left corner of the grid. Although each one has neighbors nearby, none of them has a building in all 4 directions simultaneously. As a result, there are no covered buildings, and the answer is 0. Example 3. Input, n equals 5 buildings of 2D array of 1, 3, 3, 2, 3, 3, 3, 5, 5, 3. Output, 1. Explanation. In this configuration, the building at array of 3, 3 is placed in the center of a plus-shaped pattern. It meets all the directional requirements because it has a building above at array of 1, 3, a building below at array of 5, 3, a building to the left at array of 3, 2, and a building to the right at array of 3, 5. No other building meets those conditions, so the total number of covered buildings is 1. All right, now let's walk through the solution code step by step and understand exactly how it works behind the scenes. We are given a set of buildings placed on an n by n grid. A building is considered covered if there is at least one building above it, below it, to its left, and to its right. Our goal is to count how many buildings satisfy all 4 of these directional conditions. Let's break down the approach used in this solution. Step 1. Preparing helper arrays. We start by creating 4 arrays. Rmax and Rmin will track, for each column, the maximum and minimum row positions of any building in that column. Cmax and Cmin will track, for each row, the maximum and minimum column positions of any building in that row. So the idea is simple. For any coordinate xy, the column y will tell us whether there are buildings above or below. The row x will tell us whether there are buildings to the left or right. We initialize them like this. Rmax and Cmax start with zeros. Rmin and Cmin start with very large values, so any building will update them immediately. Step 2. Populating row and column extremes. We loop through every building in the input. For each building at coordinate xy, we update the maximum and minimum row values for column y. And we update the maximum and minimum column values for row x. This effectively tells us, in column y, what is the highest building? What is the lowest? In row x, what is the rightmost building? What is the leftmost? Having this information pre-computed allows very fast checking later. Step 3. Counting covered buildings. Next, we initialize our answer counter. ANS equals 0. Then we scan all buildings again using second for loop. This condition is the key. To determine whether a building at XY is covered, we check. Above, there must be a smaller row value in the same column. That means rmin y less than x. Below, there must be a larger row value in the same column. That means x is more than rmax y. Left is more than rmax y. That means cmin x less than y. Right is more than cmax. If all 4 conditions are satisfied, we increment the count. Step 4. Return the result. Finally, we simply return the number of buildings that were covered. This solution is extremely efficient because instead of checking every building against every other building, we pre-compute boundary values for each row and column. That gives us constant time checks for each building, resulting in a clean and optimal approach. All right, now that we've fully understood the problem and walked through the optimized solution, it's time for the best part. Let's hit that run button and see what happens. Ta-da! Great! The code executed successfully, and our sample test cases are all passing exactly as expected. That's a good sign. Now let's take it one step further. We're going to hit submit and check how it performs across all hidden test cases. And perfect! We got the green checkmark. Our solution passed every single test case with full efficiency. This approach works because we pre-computed the minimum and maximum coordinates for each row and column, allowing us to determine coverage in constant time for every building. Super clean, super fast, and it scales beautifully for the entire grid. All right, everyone, that wraps up today's LeetCode Daily Challenge. If you found this walkthrough helpful, make sure to like the video. Drop a comment if you want explanations for any other problem, and subscribe for more clear, structured breakdowns just like this. Thanks for watching, and I'll see you in the next one.